Hey, good afternoon. Let's talk about the review for our first exam, our midterm for this systems engineering class, IE 4399E and IE 5397, depending on whether you are an undergraduate student or a graduate student. And the idea of the review is just to go over the format of the exam and also discuss, or not discuss, but go over the topics that were covered during this first part of the semester. And then finally, we are gonna talk about the instructions on how to access the exam, how are you gonna submit your answers, and how much time you're gonna have to complete the process. So that being said, let's get started. I'm recording the review, so I will be posting the video this afternoon in case you want to look at the video after we are done with the review, and also to give access to those students that were unable to connect. So our first exam is going to be on Thursday, March 11. The exam is going to get started at the scheduled time for the class. So that will be 3:30 p.m. So at 3:30 p.m., you will be able to go to Canvas. The exam will be located in the modules. So as you do to access the lectures, you will go to the modules, and in the module for March 11, Thursday, you'll find a link to access the exam. And you're going to be answering the exam from the computer. There are two parts for the exam, two sections, and those are listed in this first slide. So section 1 is 20 points, and you have 10 questions that could be true or false or multiple choice questions. So those 10 questions you're going to be able to answer by just clicking on the right answer for the question. And again, it's 20 points, 2 points each, 10 questions. And then the rest of the exam are, or the rest of the points for the exam are in section 2, in which you're going to have 3 to 4 topical problems related to the material that we have covered in this first part of the semester. So these could be questions related to drawing diagrams or explaining some of the things that we have discussed, such as the system lifecycle model, the system engineering method, and so on. So you will see a combination of problems in this section. Again, could be drawing one of the diagrams that I have discussed during this first part of the semester, or it could be for you to explain, describe some of the concepts that we have mentioned and addressed during this first part of the semester. So a total of 80 points will come from section 2. So in total, you will have 100 points, and that will be your exam. Any questions about the format? So for you to answer these questions, and I'm gonna go over this again towards the end of the review, you will have to, like if you have to draw or you have to write, you will do that in a piece of paper, like you would do in an in-class exam. You will take a piece of paper and you're gonna answer the question. And then what you will do, you will scan that piece of paper, or you will take a picture of that piece of paper, and you're gonna transfer that to your computer. You can save it as a PDF or in any other format that is easy to access. I'll prefer PDF, but if you, yeah, so if you can do it in PDF, that would be great. There's several apps that will allow you to take a picture and convert that into a PDF file, so you have enough time to find out how to do that in your phone. Or if you have a scanner, you can do that as well. The idea is that you answer the question in a piece of paper, and then you upload that into your computer, and so you can upload that file to the exam. So you will see in the exam, if you have 4 problems, you will have a button to upload a file. So you have 2 options. So for each question, again, you can upload a single file. Or if it is easier for you and you want to upload just 1 file without all the answers, you can do that as well. Okay, so you can, again, you can just go question by question and open and upload a single file for each question. Or if you want to save all the answers into a single file and upload just that file to one of the questions, that's fine. You can do that as well. So whatever works better for you. You will have additional time to complete the uploading. So I'm going to let you work on the exam from 3:30 to 5 p.m. At 5 p.m., you will notice that the exam will not close. The reason the exam is not going to close is because I'm going to give you up to 5:15 to upload the materials. So my recommendation for you is to work on the exam until 5 and make sure that you use the 15 minutes after that to upload the papers to the system. Okay, so that's my recommendation. Make sure that you save enough time for you to upload the files into the computer. The other thing I was going to say, sometimes there's some students that have problems with uploading the files into the computer. So sometimes the system will not let them do that. I have seen like 1 or 2 cases in this past year. So if that's your case, don't get scared. As soon as you find out that you're unable to upload the files, you can send me an email with the files and I will accept those. Only if you face problems with the system. Okay, so the reason I'm saying this is I don't want you to receive an email like 20 minutes after the exam is closed saying that you have problems. That would not be acceptable. You will have to send me that email before the 5:15 minute mark. Okay, so make sure that you try to upload the files. I will know. I mean, make sure that you really have problems with the system, because the system is going to notify me if there's some issues. I can see the log in the system and see what the student is doing during the exam. So as long as you work on the exam, you save at 5 p.m. I mean, I will be able to see if you stop at 5 p.m. with the log. So you should stop at 5 p.m. and make sure that you upload the files. If you send me an email at 5:15 and I go to the log and I see that you answered questions at 5:05, 5:10, 5:12, I will not accept the exam. Okay, so make sure that you go by the rules and you'll be fine. Then the topics that are going to be covered. So lecture 1, we have 3 parts for this first lecture, which was the introduction to systems engineering. And in this first lecture, we talk about different things. This is basically the groundwork. We did an introduction, we did the definition of systems engineering, the origins, the viewpoint, how is systems engineering different from other disciplines in engineering? What is the power of systems engineering? What are the domains, the fields, the approaches, and the activities and products? So again, this, as the title says, is an introduction. So here you get the initial concepts about what this discipline is all about and how is it related to other engineering disciplines. And also we discussed some of the tools that are available, like diagrams, and so on. So you should be familiar with those as part of in preparation for the exam. After the introduction to systems engineering, we talk about system thinking. So this is basically the theory or the theoretical framework for what systems engineering is. So we talk about what is system thinking and how is it connected to systems engineering. We also discuss the basics models for system thinking. We discussed the fundamental system construct, so you should be familiar with those. You should be able to know the difference between the fundamental system construct and the fundamental system principles. And we also did a classification of systems, and we discussed causal loop and influencing modeling. In addition, we talk about the n-squared charts. So after lecture 2, we transition to lecture 3, which is the structure of complex systems. So in this part, we talk about the system development process. We should know for the exam. We talk about the systems engineering technical knowledge. So this is an important concept. In this one, we spent some time talking about the hierarchy of the system and how deep the knowledge should be for a systems engineering. So remember, systems engineer goes up to the component level. Under that, we have the specialist. So our understanding of the system should go up to the component level. Other specialists that are going to be working with you will be more familiar with the details under the component level, but you should have at least an understanding of the system at the component level. The hierarchy of complex systems. So you should know the hierarchy. What is systems of systems, the system building blocks, the system environment, and how that impact the performance of a system. And we also talk about the interfaces and interactions. There's one topic here. I skipped this one, so I'm going to remove this. I skipped this one because of the winter storm. So I needed to look at where to cut some of the material. I might talk about this if towards the end of the semester we have more time, but you shouldn't worry about that. Okay, so Samurai, 7 Samurai, that's not part of the exam. Lecture 4, this is on the system development process. So in this one, we talk about the systems engineering life cycle model, the system engineering through the system life cycle, the evolutionary characteristics of the development process. So in this one, we have a table in which we spend some time talking about how each piece of the system life cycle is connected to the systems engineering method. So how they connect, that's important. So that's bullet number 5, systems engineering through the system lifecycle model. The evolutionary characteristics of the development process, and finally, the systems engineering method. Part 3 was the last lecture for this first exam. And in this one, we transitioned to the theory of the system design. So initially, we went through some of the concepts about systems engineering, the process, the life cycle, the systems engineering method. Now, in this lecture, we're transitioning to the actual design of a system. And we discuss 6 different types of system requirements. So you should know about those and how those were used to, for example, develop a functional system design. So how do you go? What requirements are needed for you to describe a functional system design? What requirements or what type of requirements are needed for you to describe a buildable system design? And also, again, for the implementable system design. So you should know the 6 different type of requirements and how they are connected to these different designs. So that's the last piece of in terms of material covered for this exam. In terms of how to study for your exam, you can read from chapters 1 through 4 actually from your textbook, and that will give you like an additional it's going to go deeper in terms of the concepts that we talk about in class. But if you study the lecture slides and the homework and the labs that we did in class, you should do very well in this exam. This type of this class is a little bit different from most of the courses that you take, at least at the industrial engineering level. Because here, for example, for some of the questions that you will see in the exam, there's no specific right answer. Okay, so for example, if I ask you to draw a causal loop model, it is almost impossible to get the same causal loop model for every student. But the idea is that you are able to show me something that makes sense and that you're using the right symbols, and you are describing, for example, in the causal loop model, what an arrow, what if you have 2 different type of arrows, what each type of arrow is representing. So when I read the diagram, I understand what you're trying to represent. So for example, you will see a question in which I'm going to ask you to draw a causal loop model. I will ask you to draw the causal loop model. You will present that diagram in the exam, and I can ask you questions about your causal loop model. That could be a problem in the exam. So those are the type of questions that you will expect. Again, if I ask you to draw an n-squared chart, that you understand what an n-squared chart is and how you draw one. And if I present you with a specific situation, then you are able to address that situation, and you are able to represent an n-squared chart for that specific situation. Other questions could be for you to, let's say, the systems engineering method, that you state the steps and you briefly describe what each step of the system engineering method is doing. So those are more in terms of the concept. Those are obviously, for those I will expect the right answer. But if you have a diagram or a diagram that you have to develop, actually we'll expect that those are not the same between students. So just be aware of that. The exam is going to be closed book and notes. So make sure that you study for the exam. I'm going to turn off the modules during the exam, so you will not have access to the modules. So in preparation for the exam, make sure that you go through those and you're ready for the exam at 3:30 on Thursday. Clearly, you show your work and all formulas used in your solution. So in this case, no formulas will be needed for the second exam. Towards the end of the semester, you will have more formulas. But for now, you don't need to worry about formulas. But make sure that you show the whole thing. Like if I ask you to explain something, make sure that you explain that. If I ask you to answer a specific question, make sure that you answer the question. If I ask you to draw a diagram, make sure that you include all the details related to that diagram, and so on. So the more work you present in the solution, the higher the chances that if something is wrong, you will get partial credit. The multiple choice true or false questions, you will answer those using the computer. And as I mentioned, for the 3 to 4 questions or problems, you will have to upload a file. And for these problems, you will have to work on a solution in a paper. You will take a picture or scan that document, and then you will upload your solution in a file. As I mentioned already, you will have 15 minutes to upload the files. So make sure that you start working on the exam at 5 p.m. and that you use the time after 5 p.m. from 5 p.m. to 5:15 p.m. to upload the files. The exam will close at 5:15. So that's all I have in terms of the discussion, in terms of the exam. So now you have the opportunity to ask questions. So if you go ahead.
Yeah, I had a question. Like the first part, I noticed that you had like define like systems engineering and like define like system engineering thinking. But
Yes.
I went through the lecture notes, and there's almost a lot of definitions for that. Is there a particular thing that you want us to focus on those definitions?
For are you talking in general, or you're talking about systems engineering in particular?
Well, yeah, systems engineering, particularly that. Like, what is a systems engineering? You know,
Yes.
definition.
Yes. So you're right. Let me open the right. So for systems engineering, we have multiple definitions. See where they are. Yes, but I mean, if you look at those definitions, you'll see that they are similar in terms of what they're trying to describe. Something. So this is the main definition. If you want to look at it this way, it's a set of interrelated components. I mean, this is in terms of system by itself, set of interrelated components working together towards the same common objective. And when we talk about systems engineering, we need to make sure that we are constraining the applications that we are trying to work on, to make sure that those are complex. So this will require them to have some type of diverse elements, and the way that you will know whether or not a system is complex is that most of the time that will require the development of some type of new technology, something that has not been used, or a combination of parts that have not been used before. So that's what makes this a complex endeavor. There's some other concepts that are, I mean, again, similar, but they represent something else. So engineer system. When we say engineer system, we are referring to systems that are excluding living organisms. And I mentioned this in the introduction to make sure that we understand that we will not be dealing with living organisms in our class. But where are the definitions? So here are the definitions. And as you mentioned, there are multiple definitions here, but the main idea, what I will say it is, if you look at this definition, they are similar in some sense. You will have the design, the development, the production, the maintenance. You have all this process that will take you from an idea to the actual implementation of this solution, of this, let's say, machine, or let's say process, or let's say database. So at the end, you are following the same steps in order to achieve that common goal. This endeavor was multidisciplinary, is complex, and is focusing on solutions that are not related to living organisms. So these are not systems that are alive. So they require some level of new technology to be developed. So let me see. So I'm not going to be asking you to define. I mean, that's not the type of questions that you will see in the exam. I'm not going to be asking you to, okay, go define systems engineering, because again, as you saw in class, there are multiple definitions, but I can ask you about the important details, like the things that I've been mentioning in class. You require a multidisciplinary, it's a multidisciplinary endeavor. It requires some type of development of new technology. It is interdisciplinary, I mentioned that already. When you look at a development of a systems, of a system, you're looking at three major areas of evaluation. You're looking at the cost, you're looking at performance, and you're looking at the timeline, the schedule. So those are also important details. So the endeavor that you are, or the selection of the concept that you're going to be moving forward is going to be the one that is providing you with the best balance about these three areas: schedule, cost, and performance. And yes, so I don't know if I'm answering your question at all or confusing you more or not, but the idea is,
No.
yeah,
Yeah.
yes. But the idea is that you can see that the relationship between these definitions that we have discussed in class, and you will see that the details are the same. It's a complex endeavor for an engineer system, meaning that you're not looking at living organisms. It has a societal purpose, right? So you're trying to make society better, or you're trying to solve that is a societal problem, and you are trying to balance these three areas: performance, cost, and schedule, in order to achieve that goal. So yeah. Any other question? If you don't feel comfortable asking the question through this method, you can always send me an email, and I can address your questions via email. That's another option that you have. Okay, so if there's no more questions, then again, the exam is going to be available on Thursday at 3:30 p.m. So you will have access to the exam through the modules. This set of slides is already available in the Canvas site. So after we conclude this discussion, I'm going to save the video, and I'm going to upload the video also to Canvas, so we'll have access to that. And feel free to email me if you have more questions. The exam should be, I mean, if you go through the lecture, if you go through the homework, you should be able to do very well. Just be conscious about your time. Make sure that you save some time to do the diagrams. If in time yourself in very well, so you can have enough time to complete the questions, and also to upload the materials. The reason I'm saying this, like, I don't want you to spend 50 minutes drawing a causal loop model, for instance. So because that will leave you with very short amount of time to work on the rest of the exam. So if you're gonna do a causal load model, make sure that you put 15 minutes, 15 to 18 minutes, and you save time to do the rest of the exam, and so on. Okay, so be conscious with your time, and if you do that, you should be able to do very well. Okay, so if there's no questions, then I'm going to stop the review now. And again, make sure if you have questions, you can email me and I will answer those via email. Thank you.
Okay, thank you.
Bye-bye.